Hey, so we're going to talk about finding the slope of a tangent line of the equation at the given point. To get the slope of this tangent line, we're going to have to find the first derivative, because the first derivative helps us determine the slope, aka the instantaneous rate of change of a point. But in order to get the first derivative, we're going to have to use implicit differentiation because the way the equation is written, we can't really solve for y, because in order to solve for y, we would have to do the square root. And when we square root, we technically get two options. We get the positive version, we get the negative version. So because we get both, it's just easier to do this using implicit differentiation. So our goal is, and excuse my sloppy handwriting because it's kind of weird to draw on your screen right now. So just bear with me. We have x squared plus 4y squared is equal to 4. And what we're going to do is we're going to take the derivative of that equation. So that's why I write the d over dx. So in order to do that, we can just go ahead and use our power rules for this. It's not too complicated. So from the x squared, we're going to get the 2x plus from the 4y squared, we're going to get an 8y. But because it's a y and not an x, we're going to write the dy dx to denote that we're finding the way that the y changes with respect to x, and that should equal the derivative of a constant, which is just 0. All right. So now from here, our goal is to get the dy dx by itself. So just add, subtract, multiply, divide, whatever you got to do to isolate the dy dx. So we're going to get 8y dy dx is equal to a negative 2x, which means that the dy dx, hopefully I have enough room, yep, nailing it, would have to equal a negative x divided by 4y. Cool. So in order to get that slope, we're going to have to go ahead and use this equation down here, which I'm writing in the blue box. All right. So if you note, they tell us what the x and the y values are. They're telling us that x will be the square root of 2 and y would equal the negative 1 over the square root of 2. So we're just going to go ahead and plug that in for the x and y, which, yep, right there. So dy dx would have to equal negative radical 2 divided by 4 times negative 1 over radical 2. All right, which then if we try to simplify a little bit, the negatives cancel out, so we're going to have square root of 2 divided by 4 over the square root of 2. Since we're dividing by a radical, algebraically, it's like having square root of 2 times the reciprocal of your denominator, which would give you, technically that's over 1 for the numerator, which would give you a square root of 4 over 4, which would just give you a 1/2. So the answer to this question would be that dy dx should equal 1/2 at the given point. And that's all you have to do for this. Hopefully it's been helpful. Thank you.